Hello everyone and welcome to Michad's Shooting Bench. In this episode we're going to be talking about what is a cartridge, or commonly known as a bullet. You'll hear people use the term bullet interchangeably, but bullet's only part of the equation. Basically, most people will say bullets, but people who know, all the components, they'll say cartridge, because it's a combination of components that actually make up the cartridge that you actually put into the gun. So let's clear up a few things. This right here is an empty cartridge case. This is for a 357 SIG. This is an empty case. It's made out of brass. This is what holds the primer. You can see there the indentation. That means it's spent. This is what holds the powder inside, the smokeless powder, and it also holds the bullet in the end. And you can see there's no bullet in this one, so that's ejected. Here is the bullet. This is a 40 caliber bullet from a Smith & Wesson. I pulled this 40 Smith & Wesson, and it's a jacketed, just ball ammo. That's what people will call this. It's a lead bullet, as you can see on the back there, covered by a copper jacket. So we'll put those over there. Now, as you can see here, we've got some common examples of bullets. Here's a 32 ACP. This is what's known as a ball or round nose FMJ 32 ACP. This is a 71 grain bullet. And when we say grains, that's basically an expression of how much the bullet weighs. So this one's 71 grains. The 9mm over here, that's 124 grain. This is 158 grain. It's a 38 special round. And these 22s, this one's a 36 grain. This is a Stinger. And then this one is a 40 grain, just 22. But this is a 71 grain bullet. So basically what happens is when the gun is fired, the firing pin hits this little silver circle. I don't know how well you can see that. That's called the primer, and that's basically like caps you used to use when you were a kid, and that causes a small explosion inside the case, and the flame shoots through this hole in the bottom of the cartridge case and ignites all the smokeless powder inside the case, which causes pressure to build up and forces the bullet out of the end of the barrel. Once the bullet's ejected, the gun cycles and the empty case is kicked out, and then you can pick them back up for reloading. So for instance, these 38 specials you see over here, this is a 38 special that I reloaded. It's got a truncated cone bullet. These are just regular lead bullets that I use. This one is loaded with Trail Boss. As you can see, I actually have the recipe. It's a 38 special with 3.2 grains of Trail Boss and a 158 grain lead, more or less round nose. The data is somewhat interchangeable, loading data, but so we'll put that over here. And then here's a factory 38 special lead round nose. For years, this was the standard police load in a 38 caliber revolver. The problem was the lead round nose tended to glance off things, and really wasn't that effective of a man stopper. It only caused just straight through and through wounds. Didn't really disperse any of its energy in the target. So that's when they came up with the hollow point. So as you can see, this is a little bit different. This has a hollow cavity inside of it. So what happens is when that bullet hits, fluid and tissue push inside that cavity and cause it to mushroom out. So as you can see here, here's a 9mm bullet that I fired into a Kevlar vest, and it's mushroomed out. You can see on the back here, and that's a pretty impressive mushroom. I think this is a plus P round, but basically that's the intent of the hollow point. And as you can see, like here with this 9mm, this is a Winchester PDX round. I think it's 124 grain. That's a hollow point. And I fired this into some wet pack, and that was the result. It didn't fully expand, but I mean, it wasn't the best test media. So, but that's a 9mm, and it still uses the standard. It's just a nickel case here, and same primer and everything. And then if you move down here, we've got 22 caliber rounds. I've got some Remington and some cellular and billet 22 long rifle. Now, the big difference here is with, for instance, this Remington round nose 22 long rifle. As you can see, the round, the cartridge case and the bullet, they're both the same diameter. The 22 long rifle uses what's called a heeled bullet, meaning that there's a subcaliber heel that's down below where you can see in this cartridge case that allows the bullet to be stuck in there. And basically, with these ones, this cartridge case, the bullet itself is 0.357 in diameter, looking at it straight on if you were to measure the bullet with a caliper. But the case might be 0.359 or 0.360 because there's no subcaliber heel. Well, with this, the bullet as well as the case would measure out at 0.22 or some measurement like that. I'm sure there's a tenth in there. So this uses a subcaliber heeled bullet. This does not. Most cartridge cases do not use a heeled bullet. The 22 long rifle is an exception. 22 long rifle also is not reloadable because it's a rimfire cartridge. So basically what happens is the firing pin strikes on the rim of the cartridge case as opposed to in the center, and the priming compound is all around the rim of the cartridge head. If you look here, this is the cellular and billet is a little bit different. It's coated with lubricant, that's preservative, I guess, to keep moisture and stuff out of the round. This is much older ammunition than the Remington. Another curious type of ammunition is called the Stinger. It's made by CCI, and it's basically an attempt to get higher velocities out of the 22 long rifle bullet and cartridge. Now, if you look here on the Stingers, you'll notice that the nickel-plated Stinger case is just a little bit longer. Well, what they did was they used a lighter weight 22 caliber bullet to make the case longer to allow them to put more powder in there and get higher velocity. Because as you push down bullet weight, you can make the case longer. The bullet gets shorter. So that's just an interesting derivation of the 22 long rifle round. But I hope you enjoyed this little episode on bullets and some differences and some different types and what they are in particular, and thanks for watching.